Imagine that the same shift is happening across the entire planet. People start using their brains at full capacity. How could you even notice that? If you don't look at emotions or words, only at actions. Everywhere, a reality check begins. Measure, compare, rule out chance, confirm results. Any system that once relied on habit restructures itself around rules and control. In medical institutions, no one talks about miracles. They run a series of identical tests on memory, attention, and information processing speed, record the results in unified forms, and upload the data into shared tables. Devices are verified against standards to distinguish real human improvement from technical errors. Treatment protocols are cross-checked line by line, ambiguous phrases removed, and verbal agreements replaced with checklists. Registries reduce manual input. Data is pulled automatically to eliminate omissions and typos. And what happens where mistakes are most costly? In transportation. Dispatch centers act as if a massive audit has begun. Some routes are temporarily stopped, not out of fear, but to double-check instructions, risk matrices, and failure response procedures. Then operations resume under updated rules. Fewer by-eye decisions, more if-then points. Have you ever seen how quickly flow changes when uncertainty is removed? That's exactly what's happening here. In education, traditional lessons are replaced by short understanding checks. Not learn it, but show that you understand it. Errors in textbooks and definitions are found en masse and immediately cross-checked between institutions to prevent divergent versions. Materials are rewritten in plain language, where every term has a single meaning. Assessment shifts toward practical actions judged by clear criteria rather than long-written answers. And here's the main sign. A unified data language emerges. Report formats, metric names, measurement rules. Everything is standardized. It may seem dull, but this is what a sharp rise in efficiency looks like. Fewer guesses, more verification. Are you ready to look further and see how this approach transforms energy, finance, and everyday decision-making? Now look at the places where knowledge usually accumulates over years. Schools, colleges, universities, training courses. If the brain operates at full capacity, does that mean learning becomes unnecessary? The goal doesn't disappear. The method changes. Instead of long lectures, quick understanding checks begin, and the material is immediately adjusted to match the result. That's what you do yourself. Measure first, then fix. It starts simply. Assignments are shortened into small blocks that show whether a person has grasped the meaning. Not retelling, but action. Solve a problem. Assemble a diagram. Explain a rule in one sentence. Find an error in an example. Answers are compared using unified criteria to remove dependence on eloquence. Where people once argued over wording, they now introduce precise definitions and consistent symbols. Terms are standardized so that one word doesn't carry different meanings in different classrooms. Next comes a large-scale revision of learning materials. Textbooks, manuals, and tests are checked for contradictions and outdated statements. Mistakes aren't just flagged. They're traced back to their sources. Where the rule came from, what data supports it, and what its limits of applicability are. Anything that can't be confirmed moves to the hypotheses section or is removed. Correction lists are collected into shared databases to keep edits consistent across editions and prevent them from being lost during reprints. And how is knowledge tested? Exams turn into sets of practical trials. Not recall it, but do it. In mathematics, solve standard problems with step-by-step verification. In languages, grasp meaning, remove ambiguity, translate an instruction without loss of sense. In engineering, build a model and demonstrate that it performs within specified parameters. In medicine and biology, describe a process correctly without skipping conditions and limitations. Evaluation follows checklists, done or not done, with measurable criteria. Another noticeable shift. Learning becomes personalized without excess bureaucracy. If a test reveals a gap, the system provides a short module targeting it. If there's no gap, you're not forced to repeat the cycle. Curricula are reorganized to avoid wasting resources on what's already clear. Do you see the logic? Maximum cognitive capacity doesn't abolish education. It turns it into a precision instrument. Let's move our observation to the place where the price of error is measured not in points, but in the outcome of a procedure. You might ask, what changes in medicine when the brain operates at full capacity? The discipline of execution changes. Everywhere that once allowed for approximately, or usually we do it this way, precise steps, unified formats, and mandatory checks at every weak point are introduced. Order begins with data. Medical records are converted into a single template, identical fields, identical units of measurement, identical rules of entry. Test names are standardized so that the same analysis doesn't appear under different labels in different systems. Manual input is reduced. Device results are imported directly, and doubtful values are flagged automatically. The history of prescriptions becomes fully traceable. It's clear what was done, under which protocol, and with what constraints. Then the protocols are cleaned up. Sections with vague wording are replaced by measurable criteria. Not normal, but a defined range. Not if necessary, but a list of conditions. Patient triage algorithms are built on risk factors and expected benefits, so resources aren't spent on actions without proven effect. Where two approaches are possible, preference goes to the one with fewer complications and simpler quality control. Lists of contraindications stop being a formality and turn into mandatory checks before every prescription. This shift is most visible in operating rooms and procedural units. Preparation is broken down into short stages with cross-checks of parameters: equipment, sterility, dosages, drug labeling, blood compatibility, backup plans. Errors most often occur at process junctions, and those junctions are sealed with checklists. Dosage selection and treatment regimes are recalculated based on body mass, organ function, and drug interactions, not on habitual average values. Any deviation is logged as an event with a cause, not as something that just happened. Laboratories synchronize their methods. Calibrations follow shared standards. Sensitivity thresholds are explicitly stated. Error margins are not buried in footnotes. If one test is performed by different techniques, the result is marked so that it cannot be compared incorrectly. It may sound dry, but this is exactly how the number of wrong decisions decreases. And will you notice this as a patient? Yes, through outward signs. Fewer repeat tests, just in case. Fewer conflicting prescriptions. More precise instructions. The brain working at full capacity here doesn't look like a miracle. It looks like strict safety engineering. Now let's step out of the laboratories and look at the city as a vast machine. You use tap water, electric light, heat in your radiators, and the roads beneath your feet. Yet you rarely see how many components must work flawlessly for this to happen. When the brain operates at full capacity, the city's infrastructure changes not through speeches, but through inspections and replacements. The main principle is simple: find recurring failures, remove their causes, and make maintenance predictable. It begins with inventory. Water, heat, power, and communication networks are broken down by sections. The condition of pipes, cables, manholes, substations, pumping stations, and valves is recorded. Data is unified. Identical object codes, standardized material names, precise coordinates, consistent measurement units. Where once there were scattered diagrams, a single up-to-date map is created, one that can be verified on site. Any discrepancy is marked as a documentation defect and resolved by measurement. Then comes failure analysis. If a rupture or outage recurs in the same area, it stops being bad luck and becomes a task to eliminate a weak point. Temporary patches are removed. Components are replaced with standardized parts that minimize assembly differences and reduce dependence on the experience of individual crews. Sensors for pressure, flow, and temperature are installed where calculations show parameter drift is possible. Network losses are no longer estimated roughly, but calculated by balance. How much entered, how much exited, where the difference lies. Sections with the highest discrepancy are prioritized for repair. The same logic applies to electricity. Loads are redistributed so lines don't run at their limits. Safeguards are set up to prevent local faults from cascading into wide-scale outages. Grounding, insulation, and thermal conditions are checked. Routine tests, once delayed for convenience, become mandatory. The result? Fewer overheats and fewer mysterious blackouts. And what about roads? Here too, the mathematics of flow prevails. Intersections are treated as network nodes. Throughput, queue length, conflict points. Markings are simplified, signs are made unambiguous, and traffic light cycles adjust to real-time volumes. Dangerous areas are identified through statistics on braking, collisions, and complaints, then redesigned. Islands, barriers, visibility, crossings. Public transport routes are synchronized with transfers to reduce idle time and minimize congestion. You might ask, where are the superpowers in all this? They look like this. The city stops fixing consequences and starts eliminating causes, guided by measurement and unified rules. Here's the English translation of your passage, keeping its clear, analytical tone and structured progression. Now let's look into the system most people only see as numbers on a screen. Money, banks, markets, loans, taxes. You may not trade stocks, but you still depend on how risks are calculated and how rules are written. When the brain operates at full capacity, the financial sphere begins to behave like an engineering domain. First, halt what cannot be explained. Then rebuild the processes so that every step can be verified. The first noticeable change is in infrastructure. Some automated trading mechanisms are paused for inspection, not because they're dangerous, but because complex algorithms must be explainable. Code and parameters are checked against real data to find hidden assumptions and feedback loops that amplify fluctuations. Models that cannot be reproduced and verified are removed from circulation. Instead of black boxes, the system adopts rules that make it clear which factors influence a decision and within what limits. Next, risk management is rebuilt. Risk stops being a pretty graph and becomes a checklist of verifiable conditions. Liquidity, concentration, dependency on a single supplier, currency mismatches, maturity terms, collateral quality. Reporting is standardized so metrics can be compared without translation or guesswork. Where multiple interpretations once existed, a single one now applies. Consistent definitions of income, debt, delinquency, and reserves. Shared stress test scenarios appear, repeatable across institutions, and yielding comparable results. Loan agreements also change at the level of text. Clauses with double meanings, hidden fees, or vague prepayment conditions are removed. The calculation of interest and penalties is written so clearly that anyone can check it with a calculator. Any change in rate or payment schedule is tied to a specific index or event, not to discretionary decisions. Disputes decrease not because the system grows softer, but because its formulations grow exact. Taxes and fees form a separate area. Forms are simplified to the minimum number of fields that can be verified automatically. Data is cross-checked directly between agencies to spare people from entering the same information into multiple declarations. Input errors are caught at the filling stage, not after assessment. Audits become targeted. Not check everyone, but flag anomalies by clear criteria and request supporting documents. Do you see the underlying principle? The financial system shifts from playing at prediction to building control. Transparent rules, verifiable calculations, unified definitions. For the ordinary person, it manifests simply: fewer unexpected deductions, fewer unclear terms, and greater consistency between the numbers on paper and the numbers in reality. Now imagine not an office or a classroom, but a factory, a warehouse, a conveyor, an assembly line. Here, everything depends on tolerances, instructions, and deliveries. You may never visit a production site, but you use its results every day. When the brain operates at full capacity, industry begins to eliminate randomness, because randomness on a conveyor turns into defects, downtime, and accidents. It starts with supply chains. The item catalog is reviewed and reduced. Dozens of similar parts are replaced, wherever possible, with standardized variants. Each component receives precise specifications: material, dimensions, tolerances, inspection method, storage conditions. Suppliers are evaluated not by promises, but by the stability and repeatability of their quality. Where dependence on a single source introduces risk, alternatives are added in advance, tested for compatibility. The next step is technological instructions. They are rewritten so that anyone can follow them identically across shifts and sites. Phrases like sufficient and approximately or as usual disappear. They are replaced with exact numbers, defined sequences, control points, and stop conditions. If an operation can be automated without losing flexibility, it is automated. If automation adds risk, the manual step remains, but is reinforced with a simple verification check. Quality control undergoes a radical transformation. Instead of random sampling, continuous measurement is applied wherever it matters. Sensors, machine vision, weight, pressure, temperature, electrical parameters. Defective items are not merely discarded. Each is traced to the specific process point and parameter that went out of range. The process is then adjusted so that the deviation becomes hard to repeat. Measurement results are stored in a unified format, making it easy to compare batches, lines, and facilities. Internal logistics grow more precise as well. Warehouse systems adopt shared catalogs so that one name cannot mean multiple items. Labeling becomes unambiguous. What the item is, where it came from, which batch, what restrictions apply. Material routes are shortened. Unnecessary intermediate storage is removed, and every transfer point is tracked by scanning to maintain accountability. Equipment is serviced by actual condition: vibration, wear, temperature, current, instead of fixed schedules or after a breakdown. And what does this look like from the outside for an ordinary customer? Quite simply, fewer defects, fewer recalls, fewer sudden shortages from supply disruptions. Maximum brain performance in industry doesn't look like science fiction. It looks like discipline, standards, measurements, and processes that produce the same result every time they're repeated. Let's move into the space where everything runs on information: the internet, apps, social networks, online services, and the cloud. You browse your feed, pay for purchases, store documents, talk to people, and search for answers. When the brain operates at full capacity, the first question that arises is this: how do you tell data from noise and useful tools from traps? The answer is visible in action. The network begins to be cleaned up and rebuilt so that errors become hard to hide. On the technical side, a massive closure of vulnerabilities begins. Updates stop being cosmetic. Access rights are reviewed, excessive permissions removed, and multi-factor protection introduced wherever it was once bypassed for convenience. Critical services shift to the principle of least privilege. If a component doesn't need to see something, it doesn't. Event logs become complete and readable so that any suspicious action can be traced through its entire chain. Backups and recovery plans are brought to verifiable standards. Not there is a backup, but it can be restored, and recovery is confirmed by a test. The content layer changes even more visibly. Platforms introduce rigorous source verification wherever facts are involved. Material origin, publication date, edit history, link to the primary source. Any altered image or video receives a tag marking interference, and when possible, the original version is shown alongside it. For text, statement checking against open databases is added. Numbers, quotes, organization names, geography. An error no longer hides in the comments. It's highlighted as a verifiable inconsistency. You might ask, what about scammers and spam? That's where signal aggregation comes in. Behavioral patterns of phishing, fake shops, scam calls, and bulk mailings are collected into shared indicator lists. Blocking no longer depends on a single complaint click, but on the alignment of multiple criteria: domain, payment details, repeated text, redirect schemes, traces of automated registration. Providers and mail services start exchanging threat indicators so that malicious campaigns can't migrate from platform to platform. Personal digital hygiene also evolves. Passwords give way to keys and password managers. Account access is divided by tiers. Important documents are verified with digital signatures. Privacy settings lose the allow everything option, leaving only what's needed for a function. Apps with opaque terms lose users because the terms are now read and checked point by point. And the main effect for you, the observer, is simple. The internet begins to live less on rumors and more on verifiable links, traceable origins, and change tracking. It's not a perfect world, but it's one where facts are easier to confirm and deception is much harder to scale. Now let's switch to everyday life. There are no laboratories or trading floors here, only familiar routines. Shopping, bills, arrangements, cleaning, commutes, shared tasks. When the brain operates at full capacity, what changes in this space? The way decisions are made. Not intuition, but verification. Not the usual way, but by rules that are easy to follow. Let's start at home. Spending stops being a set of random payments. Consumption lists are made, and every item gets a simple tag. Needed regularly, needed occasionally, not needed. Subscriptions are checked against actual use. Unnecessary ones are cancelled. Water, electricity, and heating are tracked with clear readings and thresholds. If a value goes out of range, the cause is investigated. A leak, an old device, an inefficient setting. Appliances are configured for modes that truly save resources, not just the ones promised on the label. Food and shopping habits also restructure. The cart follows a plan: what will be cooked, from what ingredients, and in what quantity. Labels are read for content, weight, and unit price. Impulse just in case. Purchases disappear because each product has a purpose and a shelf life. Waste reduction comes not from slogans but from sequence. First calculate portions, then check leftovers, then buy only what's missing. It may look dull, but it delivers predictable results. Digital routines become simpler. Passwords are replaced with access managers. Key accounts are protected by security keys. Backups are verified for recovery. Photos and documents are sorted into clear folders to avoid time loss searching. Notifications are limited to essentials, so Signal doesn't drown in noise. Each new app gets a check. Where does it send data? What permissions does it require? Can you manage without it? And what about everyday conflicts? The same rule applies. Define first, agree second. Terms are stated concretely. Who does what, to what extent, to what outcome. Shared chores are described by bullet points, not vague promises. If a schedule is needed, it becomes a checklist. If a payment is required, it's logged with amount and date. Disputes decrease because there's less room for differing interpretations. Movement and household logistics shorten as well. Routes are planned with connections and walking time in mind. Errands are combined to avoid traveling to the same place twice. Things get permanent storage spots, and rarely used tools are tagged so they're easy to find. Do you see the pattern? Everyday life starts to function like a simple system with clear rules. Fewer random expenses, fewer lost items, fewer misunderstandings. And this isn't the magic of an overclocked mind. It's made of everyday actions. Measure, verify, document, and repeat what works. That's how maximum clarity turns into habit, and habit into consistent results.